Next speaker is Professor Cecilia Mascolo, who is a professor of mobile systems in the Department of Computer Science and Technology at the University of Cambridge, the co-director of the Center for Mobile Wearable System and Augmented Intelligence, and a fellow of Jesus College, Cambridge. Her research interests are in mobile systems and data for health, human mobility monitoring, sensor systems, and networking and mobile data analytics.
Thank you, George. So in these brief minutes, I want to talk about the challenges, but also the opportunities. I always say to my students that to be a researcher, you need to be an optimist. So you will see optimism in this talk. So we see a lot of devices already deployed, and people wear them. And so one might think that in research we are done, and that it's really about people using it and us collecting the data, and then it's a matter of other disciplines just using the data, nothing about computer science anymore and research. Well, in this talk, I want to show you the avenues that we're pursuing, and I guess I think they should be pursued, and the issues that I still see. So I'll start with the obvious one. There are lots of sensor modalities that we are still exploring. I am a computer scientist. I don't build these devices, but I then use the data that these devices produce. This is an example of a possible EEG sensor, and we see lots of glasses that start having this sort of things. We don't know how they work. We don't know if they are still good, but lots of this is happening already. But what is perhaps more tangible and interesting is the fact that we have devices already out there that can be used. People are using them. And so for public health, they're already in the hands of many. And they have sensors that might have not been used for the idea of then monitoring behavior, monitoring health. I'll give you an example. The accelerometer on a mobile phone was initially used to play games. So they were playing, I don't know if you're old enough to remember that we could play games to tilt the phone and put the ball into a corner. And now the accelerometer is the main way we monitor the number of steps, for example. And so the other aspect, which I think is very important, is the fact that these devices, and I think Andrew already hinted at this, he scooped me somehow, that they give a view of the user which is continuous. You have, all of a sudden, a longitudinal perspective of what a user is doing by following them in their daily life. Let's see what this means. So how do we monitor sleep? If you are familiar with this is polysomnography, a version of it, let's say, where a person is put into a lab in a very, I don't know if you can sleep like this, but I can't sleep like this. So you go into this lab and you have tubes and things attached to you. And this is the gold standard for monitoring your sleep. Now, one, I will never sleep well, not even if I stay a week. But we have this. This is a paper published in 2021 that I show my student. If you look at the title, Consumer Devices, Not Good Enough. And if you look at the paper, the apps are not good, the devices that you wear are not good. So this is a very negative view of how this compares to polysomnography. Well, as I said, I'm an optimist. And here is my view. This is just an app. It's not on the watch. I won't mention the name. But I just screenshotted what they can do just by having this app on the phone. The monitors perhaps how much you're using the phone at night. It might monitor, some of them monitor your audio, some monitor some other things. You can put them on the bed, there are a variety of them. But just by using an app, not even a watch, they can say things, statistics, because they have, the amount of data they have about me is not just one night in the lab. It's a set of nights, very imprecise data, that we can start making sense of. So here is, I think, from the computer science perspective, here is where we really need to crack and where we need to go to help the science. The other thing that I like is, I love this picture, so these devices listen to us. So I'm doing research also on microphone, you'll see some of it today. So they stay and listen to our body all the time. And I had a conversation with clinicians where I told them, what if I put something on on your abdomen that would stay there all day. If I give you this data that hears the sounds there, what could you do with it? And even this conversation is difficult because they never had this data. So in turn, they have to think of what they could do with the data. And so that kind of conversation needs to happen to make this useful. The obvious other thing is that all of our studies with these devices are with small numbers. They are with small numbers because we need to get the famous labels. To train anything machine learning in the traditional way, we need to know if the person, if I go back to sleep, we need to know if the person was sleeping, what kind of sleep phase that was in order to assess if the watch was able to monitor that. So to do that kind of study and gather that kind of label is very, very hard. And it's very time-consuming. And so if we do that, then we will end up with a small data set. Can we do something where, Apple, Google, other companies start having billions of data points for individuals? And so what can we do with that data without the labels? Lots of researchers are already working in this area. It's a very important area for wearables because the labels here are very hard to get. And this is a slide I stole. No, I didn't steal because I'm acknowledging. That's a person I would have liked to have here. Is a colleague that works in public health, the public health department in Harvard University. It slides the data and analyzes all his. So this is, I will explain. This is a graph of heart rate variability. How many of you know what heart rate variability is? Let's see how many. I expected more. So heart rate variability is how your heart rate changes in terms of periodicity and heartbeat, how the difference between the beats, the length, the duration between the beats changes over time. If you're very stressed, your heart is very controlled, your system controls it, and it gets very regular. So it's not a good thing. So your heart rate variability should be high to be good. Now, this is a data set collected. So a person in their group had their data, I can't remember which device. I don't want to remember which device this was, which type of device this was. But they collected the heart rate variability. They got the data from the server of the device at one point in time. They went back to it a few months later, re-downloaded the same data for the same period. And this is how the difference was between the data. So this is first export, second export. The data was different. If you're doing a study with this data, depending on when you download the data, your data is different because the company changed the algorithm used to determine the heart rate variability. These are the challenges that we have. And obviously, we don't see any of that. Luckily, there was a correlation, you'd be pleased to know. I have about 1 minute, but so privacy. I cannot talk about privacy because I'm sure in the next talk it will come up. My view on privacy is incredibly important. If you work like us, you will see a talk on GPS data. We cannot assume that this data is just useful. It is useful, but it's very sensitive. So one way in which these things could be helped could be by possibly making sure that these models, once developed, can run on the device of the user. And I use this, some of you might understand this, this concept of clinical trial. My clinical trial idea is that I need this data collection to happen on the individuals of my clinical trial. So I need to collect the real GPS traces of a large cohort. But then when I develop my algorithms and my machine learning, I can put on the device of the billions of people a machine learning model that allows me not to download the data onto the server, but just to keep it to the device. That's one approach. Many people are working on many other approaches, such as federated learning, for example, and this could be another solution. I'll leave it there. You can ask me questions later. And I think in the interest of time, I'll skip this and say that actually it's these people that do the work, and it's not me. So, yeah, thank you very much.